Hello, everyone. My name is Albert Chon. I'm the co-founder and CTO of Injective Labs. And today I'll be talking about the AppChain revolution, redefining DeFi through cross-chain integrations. So Injective is a blockchain built for finance. Our focus is on powering the next generation of DeFi applications and providing powerful, advanced DeFi infrastructure and primitives for builders. So first, I'll talk a little bit about the Injective ecosystem. The Injective ecosystem is one of the fastest growing ecosystems in all of Cosmos, with numerous DeFi applications and integrations building on top of Injective. And I'll speak a little bit about interoperability. So interoperability is at our core. Injective connects with numerous blockchains through IBC, through with Axelar and Wormhole, and even our own native Ethereum bridge. But for us, interoperability extends beyond just blockchain bridging, but also within the chain itself. And most importantly, compared to other limit order book DEX protocols, the order book on Injective is fully composable with smart contracts and CosmWasm. Now, CosmWasm is a great framework, and it has native compatibility with Injective. But we found that for new developers, the learning curve for onboarding CosmWasm, even if they already know Rust, is quite high. There are many concepts specific to Cosmos and CosmWasm that you have to learn. And as we spoke to many developers, especially those coming from Solana, we heard these criticisms and difficulties for them to even deploy their basic application. Basically, they'd have to not only rewrite their application code, but have to learn all these new concepts and security guarantees. So we took these considerations to heart and tried to build a solution for them that they could use. And that is Cascade, which is the first Interchain Solana SVM rollup. So with Cascade, developers from Solana can utilize all of the benefits of the SVM and create applications that leverage IBC and cross-chain interoperability, which I'll explain in more depth. So first, I'll speak a bit about integrating rollups from an AppChain's perspective. So first, why should we integrate a rollup, particularly an SVM rollup, and why does this make sense for Injective? The first is that it provides a diverse programming environment, and it lowers the barrier for entry for developers coming from the SVM or even the EVM world with EVM rollups on Injective. And second, horizontal and vertical scalability. So on the horizontal scalability side, you can shard your execution essentially between different execution environments. One is, of course, the SVM. The other is the native Injective layer. And on the vertical scalability side, the SVM, of course, is renowned for its multi-threaded runtime and offers parallel transaction processing, which is very powerful for scaling modern applications. And the final, but I would say most difficult piece is on interoperability, making essentially these SVM contracts be able to compose with Injective through IBC. And currently with rollups, you have a 7-day fraud-proof window, which makes it very hard to compose in a vanilla implementation. And of course, modern DeFi applications require fast finality. You don't want to, place an order for a trade, wait 7 days before it gets filled, right? That's simply ridiculous. So how can we do this? I can summarize the current approaches to cross-chain interoperability. As I mentioned, for optimistic rollups, you have a fraud-proof dispute period that you must wait for, which results in terrible UX. There are also solutions that use what are called committee-based interoperability, and these include Wormhole, Axelar, Hyperlane, and I would also categorize these as not ideal. They embed a security assumption in the validator set, and while they are useful for applications that wants to take advantage or adhere to that security assumption, I would not use them as a foundational model for, let's say, the rollup. There, of course, is also ZK and validity proofs, which, for example, ZK rollups or ZK proof of consensus by Injective Labs are developing. But these also have pitfalls of mainly slow proof generation and just the general challenge of creating a circuit that is arbitrary and generalizable. There is some interesting work with ZK IBC, which Jack Zampolin and I believe another team is working on that deserves some note that's still in development, though. And finally, there are escrow-based approaches. For example, Dimension's escrow IBC or eIBC, which essentially uses a market maker or some liquidity provider to take on the risk of having these tokens be bridged over, or basically vouchers, and purchasing or giving the tokens out on the other chain. And this approach, while it's more of a band-aid solution, it's limited and it incurs extra fees. So the next approach that Injective is exploring and wants to take is called essentially a consensus rollup. And let me see if I can get the next slide. Thanks. And the idea here is that how can we bypass the fraud-proof window of optimistic rollups, since this is a major impediment towards IBC interoperability. And the idea here is Injective validators will run a rollup full node and attest to the rollup headers on the blocks on Injective. So the mental model analogy you can use is, suppose you have a ZK rollup, but you replace the ZK proving system with just the validator signatures, and you essentially get the same security guarantee. And what's different here is that because it's an L2 of an L1 with a fixed validators, or not fixed, but a smaller validator set, you're not making any incrementally worse security assumptions than you were already making. And that's also why Ethereum would never do this, because you could never get Ethereum to sign off on their entire validator set to have to be burdened with this requirement. And just to go over the mechanism a little bit in more depth, the validators continuously track new headers of the rollup, attest to them on Injective, the mechanism of which can be done as an implementation detail using vote extensions, which are nice because they allow you to do this in process, or just with normal transactions from the validator. And once 2/3 of these validators have attested to the correct header, the header is committed to the state on Injective. And now, because it's on the state of Injective, the header can be proven using a light client, and the IBC packet inclusion can run as normal because, and this allows for you to have IBC connectivity with a rollup. I'm also very excited to announce the partnership with Espresso Systems on bringing decentralized sequencers to Injective. So Espresso Systems has, I would say, the most state-of-the-art technology in the rollup sequencer space. And our overall goal is to work towards atomic composability. For Espresso's decentralized sequencer, for its shared sequencer, actually, you can have fast finality with secure transaction ordering and strong data availability guarantees. What's interesting is that in a rollup-to-rollup setting, so in the scenario where you have multiple rollups on Injective, you can have atomic cross-rollup transactions. And this allows for, in some cases, cryptographically guaranteed cross-rollup transaction bundles, and in other cases, crypto-economically assured cross-rollup bundles. And that's using a block builder with proposer-builder separation. And the final boss to conquer, I would say, would be shared sequencing or atomic composability between Injective, layer 1, and a rollup. And there's an open question about how this can be done. It's actually unsolved. And whether it's even feasible to have shared sequencing with the sovereign L1. There are some ideas based off heterogeneous Paxos, and some other ideas like perhaps we can bring PBS to Tendermint and use ABCI++, prepare and process proposal for this. Or maybe we can even not aim for atomic composability, but have a more best effort or optimistic atomicity. These are questions that we are now pondering in this design space to, of course, eventually improve the UX for cross-chain interoperability. And taking a step back, I'd like to remark on the power of self-sovereign, interoperable, application-specific blockchains. Some of the design choices or things within our consideration would never be possible on layer 1 Ethereum, right? The concept of having validators do work for, let's say, attesting to rollup headers, that would never be acceptable in Ethereum, not to mention the slow pace of movement of development and the ossification of standards. And this is the sort of thing I guess I would like you guys to take away about when you build with an application-specific blockchain, you have a lot more freedom on every layer of the stack, from the application layer to consensus to networking and all these other requirements that you may want to impose. And it's become a lot easier to do with ABCI++. So that's it. Thanks for listening. You can follow us on Injective on Twitter. And yeah.